Well, up to now, this is the random variables. With the random variable, then we have the corresponding functions. Probability mass function, probability density function, CDF. And also we try to find the relationship between PDF and CDF and between PMF and CDF. And that's it. And next one, we want to have the expected value or expectation. So, talking about expectation, we want to have the expected value. How to have the expected value? Later, we want to have the definition for the expected value. And also, we want to know the moment, nth moment or the central moment. And specifically, we can check how to define variance. And here, let us have an example. The previous PMF. So can you let us know which point serving as the expected value? Oh, okay. It seems to be this one. 1, 2, 3, 4, 5, 6, and in between 3 and 4. And so it's 3.5. Is it true? How to define the expected value? So it says we should have a typical value. The typical value serving as the representative of the current random variable. And how to define that random variable? So it serves as the typical value or the representative of all the current values here. But we have the specific relationship to define this kind of value. And this kind of value, then we call it the expected value. How? This way. Alright, this way. Expected value, actually it's average value. And this way to define average value. Probability associated with the point, multiply the current point, and we perform the summation for all possible points. And so that we can have this kind of value. And this kind of value, then we call it is an expected value. And in fact, according to the current one, yes, you can check it. Indeed, it's 3.5. And normally, it doesn't mean we should have the middle point between 3 and 4 if we alter the probability. Alright, if we alter the probability to the other set of probabilities, then possibly we won't have the middle point, 3.5, in between 3 and 4. And this is a natural way because we have the definition. We just follow the definition, and this kind of definition we have the expected value. Well, we can have the expected value. So we have a new notation, expectation. Expectation, so E of x, expectation of a random variable x. In fact, the notation here is expected value, and it's average as well. Alright, and if we have the notation, then we can have this kind of notation. Expectation with respect to this function. And this kind of function, then it can be reduced to the relationship. And for this definition, actually we want to involve. For example, here, we have any random variable. And just related to the value of the random variable. So it can be k raised power to n. And this kind of a function we call nth moment. And if we want to define central moment, it's easy. The point k minus the expected value. Expected value of the random variable. And so that this kind of function here is called nth moment. So this page, we can have the definition of expected value. And actually, we can have the definition for nth moment and nth central moment. So we can get back to the definition for variance. Variance is simply the second central moment. All right, and based on the based on the concept of second central moment, then we can have a variance definition. Well, if we have a variance definition, is it true? We have the result like those. It's true. So how to prove this? Let me change the color. If we take here, it doesn't mean expect. Here it doesn't mean discrete. Actually, continuous is okay as well. All right, so we can base on one of these, and later I will prove it for continuous one. Right now it's continuous one. It's discrete one. So discrete one still have the equality. Variance actually equal to expectation of a square minus square of expectation. Let me read it again. Expectation of a square minus square of expectation. So this formula, this calculation equal to variance of a random variable. Well, currently we have the definition for discrete random variable. Likewise, it is valid for the continuous random variable. So look at this. For continuous random variable, previously we have a summation. At this time, change it to integral. Change it to integral, change it to integral, and likewise for this. So, continuous random variable, we have the similar definition, but we need to have integral instead of summation. And so that we have all the possible definitions. For the current one, the relationship, let me demonstrate this one valid. Why this one valid? Look at this. All right, so we can have this x squared and minus this. All right, so expanding, and then we have a square. And this one, actually here, for constant, actually we can move it to the outside of integral. And so that we have an inner side to take the total probability. So fine, it's 1, and this one actually it's e squared, e expectation again. So we have this. And minus this. And change the notation to this one. So we have a second moment minus expectation, square of expectation. So for the continuous one, yes, we follow this one. Similarly, for the discrete one, we have this relationship hold for the discrete random variable for sure. All right, that's it. So this is the discussion for expected value, nth moment, and central moment, and we have the special case of variance. For the special case of variance, we have the equality. How to prove the equality hold? I don't have the example, continuous random variable, to solve as an example to illustrate, yes, it's valid for the continuous random variable. All right, that's it. So after now, I talk about the expected value, nth moment, and central moment, and variance. And I stop here and erase all the possible discussion and allow you to check it for 2 minutes. And think about this and so that you know what I talk to you. All right, maybe 2 minutes later, let me continue. So I pause here and so that allow you to think about for a while. Why I pause here? In fact, it's an online course. So if I continue to speak, and then maybe you will fall asleep. So I try to pause, allow you to have a possible time to think about this. Almost 1 minute left. Sure, up to now, if some of you join the online course or online classes, if you have any possible questions, you can try to send me the email and so that I can, sorry, not email, send me the message on line group and so that I can check it. So wait a moment, let me get my cell phone and check possible questions on line group. Or maybe no. So at least, let me check. So any possible questions on our line group? Maybe let me check it for a while. No, so let us continue.